This lesson's gonna cover slope. Slope is rate of change. Rate of change is slope. Slope is the rate your line is changing. So it's really important to understand that those words are interchangeable. The rate of change, how fast something's going, your miles per hour, your money per gallon. Okay, that's slope, and that's why we represent it a lot on a graph that's a straight line. So when we think of slope, slope is everywhere around us. Okay, slope is in our daily lives. What is slope? You'll see slope when you build a bridge. Look at the Golden Gate Bridge. There is a slope there. A skier needs to understand the slope when they're skiing. A roller coaster, an engineer designing a roller coaster. Airplanes have slope. The picture you see at the top right that has the 25%, that's very important. If you're driving a truck and you are on a road that has a steep slope, it's important to understand that. The biggest place that slope comes in, and people don't even realize it, is in constructing of a home. Sometimes, and I'm sure some of you have seen it, there's staircases. Some staircases are steeper than others. They built in a steeper slope. But as you go up that staircase, it's the same all the way up. Another place that's critical your slope is calculated properly is on a roof of a house. And if you calculate it wrong, there's going to be a lot of problems down the road. So what is slope? Okay, slope is the rate of change between any 2 points on a line. So what you're looking at is your rise, and if you look at the graph on the right, you have a rise in the purple arrow over your run. Okay, your slope is telling you how steep the line is. This might get a little confusing for some people because the rise is the change in y. The run is the change in x. Normally, we always graph our x value first. That's the way to do it. That's how we always do it, and we are going to continue to do it that way. But when we're calculating slope, we have to figure out the change in our y, how high up it's going, before we can talk about our run. Okay, so it's always y over x. So it's always change in y goes on top. If you don't have the y on top, it's going to completely change your slope and it's going to send the line in a different direction. Can you imagine doing that on a roof? If you put the change in your x on top, the steepness of your slope of the roof is going to be drastically different. And if half the crew did the roof one way and the other crew did it the other way, you're going to have to redo that home. So you're going to hear this a lot. Rise over run. Change in y over change in x. Okay? So we can find the slope from a graph. We can find the slope from a table. Or we can find the slope given 2 points on the line. Some of you might want to graph the 2 points and count up and over. That is 100% okay. But sometimes the points are going to be really big. So you want to be able to understand how to calculate it each way. This is going to come up over and over and over, and you're going to see the letter M. It might be a tad bit confusing for some, but the letter M is how we represent slope in math. It's our rise over our run, our y over our x. But it's the change in y over the change in x. So if you need to, take a moment and pause the video and write this down, because this is probably one of your most important slides in this set of notes. It's your vertical change over your horizontal change. So there's 4 types of slopes. And this, again, is also a very important slide to have. So first, you're going to have a positive. Notice the direction of this line. It is going up. Well, how do I know it's going up? what I'm going to do is I'm going to start at the left side of my graph. Just like we read a book, we start on the left side. So you're going to go from left to right. As I go from left to right on the line drawn, it's an uphill climb. Therefore, it's positive. As I go up, it's a positive direction. Well, your other type is negative. When you have a negative slope, okay, some people get confused. They go, well, the arrows are going both ways. How do I know if it's uphill or downhill? Again, start on the left-hand side of the graph. You draw a line to the right-hand side, it's going down. That is a downhill climb. So it's a negative slope. Then you have a zero slope. So a zero slope goes from left to right. Okay? That is always going to be a y equals. All of your y's on that line will be the same. The last one is undefined. You might hear it as undefined, or you might hear it as no slope. You can't ever write zero because zero is zero slope. So when it is undefined and it goes up and down, the equation of that line is x equals a number. This one happens to be x equals 2. But when you're asked for the slope of a line like that, of a vertical line, you have to write the word undefined or the words no slope. So slope represents the rate of change. It should be written as a fraction in simplest form. So when you find your slope, we always simplify it. So let's take a look here. I've got 3 lines. Let's go find my slope. Okay, I'm going to start at this first line. See where I just drew my little pink dot? We're going to find the slope of this one. I'm on the left. I go from the left point to the right point. Always. And I'm going to first do my rise. I'm going to rise up 3. How do I know that's 3? Because there's 1, 2, 3. You don't count the point you're starting at. Then I'm going to run. And I ran 2. Now they're both positive. When you go up, it's positive. When you go right, it's positive. Just like a number line. So therefore, I have 3 over 2. Leave it. Don't make it a mixed number. Slope is the change in y, which is x, y, over the change in x. So in this case, 3 over 2. You're done. You can't simplify. Let's take a look at this one. I'm drawing my little blue dot if you can see it. So I'm starting at the left, and I'm going to rise 2. Then I'm going to run to this dot. But I am running 4. Both directions are positive. Up and right are positive. Look at my line. It's going uphill. So I put the change in y over the change in x, and I get 2/4. Okay, but guess what? Go back and look at my instructions. It said in simplest form. So 2 over 4 can be simplified to 1/2. You must always simplify a fraction. Let's go take a look at my last one. And I can look at this, and I see it's going in a different direction than the other 2. The other 2 are positive. That must mean this one is negative. So I'm going to start at this point, and then I'm going to go to the next point. You see it down there at the bottom? I went down 6. So I'm going to write a negative. And then I went right 2. So I'm going to write a positive. You're writing the sign of the direction you're going. So, okay, negative 6 over 2. Perfect. But it can be simplified to negative 3 over 1. You could even write negative 3. That is acceptable as well. Okay? It's your turn. This one is 0 over 1. If you notice, I didn't rise anywhere. I stayed on that same line, but I went to the right one. So when you have 0 on top, it is a 0 slope. Okay, let's go to the next one. Here I rose 4 and I ran 1. You can simplify that to 4. Leaving it as 4 over 1 would be acceptable as well. Let's go look at number 3. So I went down 4 and over 2. Therefore, it is a negative 2. This might be hard to see, but your blue line is on your y-axis. It's going up and down. So here, I rose 2, but I didn't run anywhere. So you have to remember, if you're doing these calculations and 0 happens to be on the bottom, that is in fact undefined. In math, this is something that has happened every year now at the math level you're at. Your teachers have always said you can't have 0 as a denominator. It is undefined. So it is important to actually commit this to memory. If 0's on top, it's 0 slope. If 0's on the bottom, it is undefined. So many of you might think that this is the easiest way to find slope. And in fact, it is. This is going to be probably your favorite way. But it's not always going to be the way because you're not always going to have the graph. Sometimes all you're going to be given is 2 points. Now, we're working with smaller numbers here, but there's times you're going to get larger numbers, and that's not as easy to just put on a graph and count up and over. So what you have to keep in mind is your slope formula is always subtracting your values. This formula right here where your arrow is pointing, the formula is subtraction. You subtract the y's from each other and then the x's. But please write this down if you have to pause. Order matters. You can't just do any y and any x. And I'm going to show you what I mean by that. So let's go look at the left-hand side for a minute. I'm going to write my m equals because I'm trying to find my slope. Okay? I'm going to go with negative 3. It's subtraction minus 1. Now, it's a fraction. So then I'm going to find my change in x. But since I used negative 3 first for my y's, guess what? I must use 0 first for my x's. Since we're dealing with subtraction, the order does in fact matter. So I'm going to write 0 first. I am then going to subtract my negative 2. Now, you have a negative and a minus, so you need to rewrite this with one sign. Your top is fine. Negative 3 minus 1, there is nothing wrong with that. Your numerator can stay. But your denominator really needs to become 0 plus 2. And we have to get over the not wanting to show work. Because with the slope formula like this, if you try and do one step in your head, you're going to make a mistake down the road. Take the time and rewrite it. It will help you. So now we're going to go subtract. Negative 3 minus 1, I'm going further back on my number line, is negative 4. And 0 plus 2 is 2. So I have negative 4 halves. But remember what we said a couple slides ago. Slope must always be written as a fraction in simplest form. So I simplified this down to negative 2 over 1. You could also write it as negative 2. That is acceptable for slope. Okay, so let's go look at my next one. Again, start with m equals. I'm going to write negative 2 minus negative 4. I'm taking my time and writing everything out and plugging it in. There's my fraction bar because slope is a fraction. Negative 3. Notice what I did. I put negative 3 first because that is the x that goes along with the negative 2y. They're in the same parentheses. Then I'm going to subtract negative 7. There's a lot of signs there. So let's go rewrite it before we do any addition or subtraction. It's really negative 2 plus 4 divided by negative 3 plus 7. Ladies and gentlemen, this is why integers are so important. It's going to be in everything we do. Negative 2 plus 4 gives us a positive 2, and negative 3 plus 7 gives us, in fact, a positive 4. Look at that. I can simplify it, and you must, to 1/2. Okay? So, showing your work, taking your time, and practicing your integer rules are very important. So now it's your turn. Pause the video and try these two on your own. Okay, let's see how you did. So we're going to start 3 minus 0. That's kind of easy. Over negative 1 minus 0. You kind of got away with an easy one here. That's going to leave you with 3 over negative 1. You can write that as negative 3. Okay? Let's go look at our next one. I have negative 4 minus 3 over, you're right, you must write negative 2 first, minus 5, because the negative 2 was along with that negative 4. So I end up with negative 7 over negative 7. Well, back from 7th grade math, a negative and a negative make a positive. But I know 7 divided by 7 is in fact 1. So this is why those operations and those signs are very important, that we have it written properly and in the right way. Our final way is finding the slope given a table. I actually really like this way, and I think it's very straightforward. When we're dealing with the slope of a line, okay, your rate of change is going to be constant. So what I like to do is I like to start with my y's, okay? I'm going to start and I'm going to find from 8 to 11, that went up 3. You need to make sure it goes up 3 in the entire table, because eventually you're going to get some that are not linear. But from 11 to 4, it went up 3, and 11 to 14, 14 to 17, it went up 3. So my change in y is a positive 3. So we go find my change in x, which here is a positive 1. So right there, you have your two numbers for your fraction. Okay, so let's go look here. Here was negative 1. Here, negative 1. And again, negative 1. But from negative 4 to 0, I went up 4, and up 4, and up 4. Notice how these two tables differ. The table on my left is vertical. The table on my right is horizontal. That doesn't make a difference. I'm still sticking with my x's, the change in my x's, and the change in my y's. So when I go put this together, I take the number. The number should be the same from all the changes. So on my first one, I have my slope is 3. Now come over to your horizontal one. I'm still going to write the change in my y first. You've got to look at your table and transfer things, okay? That's where this gets complicated. That negative 1 was the change in the y's. Your change in your y always goes on top. The change in your x always goes on the bottom. A negative 1/4 is as simplified as it can go. Well, that leaves it with your turn. So pause the video now and try to find the slope of these tables. Okay, Let's see how you did. And I added a little bit here. But if we start here, from 1 fence to 2 fence, from 2 to 3, and 3 to 4. Most of you could probably recognize that's going up by 1. Then I go up by 3 on my X's here. So what does that mean? That means I have 1 fence over 3 hours. It means I can paint 1 fence every 3 hours. That's your rate of change. This is how slope is coming in, and this is why we also call it the rate of something changing. That means in a business, it's going to take me 3 hours to paint 1 fence. So if I had to map out my day and I knew I had to paint 3 fences, I knew it would take me 9 hours. That's where we find the rate that something is changing. So let's see now, if you already found your slope on your miles per hour, can you go generate a sentence like I did on the first one and explain the rate that is changing? Okay, let's go see if you got that. So again, I'm going to focus on my Y's first. And I notice my miles increase by 70. Okay, over the course of stuff, it's increasing by 70. My hours increase by 2. So every line of my table is going up by 2. Well, that means my slope. I'm going to put my rate of change as the change in my Y over the change in my X. But I can simplify that. So really, it's 35 miles over 1 hour. This is how we calculate our speed. So what would our sentence be? You got it. I can travel 35 miles per hour. And that's how we can calculate things. If you're traveling at that speed, you're going to go 35 miles in 1 hour. So there's a lot that just got thrown out at you, okay? So feel free to subscribe below. There is more on slope on this YouTube channel, or comment below if you have a question about slope. Go back and re-watch the video if you have to. It might clarify things a second time. Pause it, jot down notes, because this is going to be your slope. This is going to build, and it's going to come into other facets throughout the year. So it's important that you understand how to calculate it.